All right, we'll move into the discussion session. But Nevin, I saw your hand up, so we'll go to you first, and we'll continue the conversation there. But let's thank Gisela again.
I can say just a little bit about Ruben's perspective. I know that we talked in January, February with Bob Lam, who is like the head of Ruben. And I think the current thinking it is that the best way would be if we could collocate the data somewhere with NASA data sets. The problem is, for instance, the easiest would be AWS buckets, but there are open space buckets, and Ruben is not open data. I think actually people here like Vandana and IPEC are people who are thinking about that. But unfortunately, as mentioned, I'm not sure that we have a good answer at this point.
Gautam, you have a response to that? Okay.
Yeah, I'll point out that for time domain, you don't actually have to collocate a whole lot of the data just because the Rubin-Roman overlap is only about 5,000 square degrees in HLWAS, and HLTDS is so tiny that it doesn't matter. So you can fairly quickly do queries to pull cross-match postage stamps or even larger cutouts using the Rubin postage stamp server. You don't actually have to collocate the data. What you do need, which I'm really glad to hear about for the first time, are these GPUs as part of the Nexus project, because any kind of multi-survey, multimodal inference is going to use AI. AI needs GPUs, and Rubin doesn't have them. So I'm glad you folks do.
So just to clarify a bit, are we talking about like the Rubin Science platform, like interfacing somehow with the Roman Research Nexus, or Roman being able to access Rubin databases, or both? Okay, yeah.
I think the only way you could do now, you can pull Rubin data with TAP. If you have a Rubin authorization, you can pull data via TAP outside of the Rubin Science platform, and that will, it's API. The throughput that you get through TAP is the throughput that you get through TAP.
Okay.
Or you can just bulk download on your own. And
yeah, that's true. With it there. So we'll go to Sebastian, and then Mansi.
So obviously I can upload my own data and keep it in my account on the Nexus, but is there a way to have a public repository where I can say upload a data set and anyone in the world can look at it, so that we don't all upload the same thing multiple times?
Yes, so we're gonna have a public S3 bucket where data that is deemed appropriate to be public can be staged for a certain period of time, and that's within our MAS service. Note that any data in there will be part of our open data bucket policy, so people will be able to, egress it, use it fully openly.
So I just want to respond to the Roman plus Rubin question. So one thing I wanted to clarify is in the rapid alert packets, we are trying to include the Rubin history. Yeah, so it'll be published so that as soon as you get no matter which event broker you use or how you access the rapid alerts so at least for time domain, and that doesn't answer everything, right? But at least for time domain, where you immediately need to know whether or not there was some Rubin history at that position. That is something we are hoping to just add to the metadata in the alert packets.
Okay. We'll go to Rebecca and then Leo after.
And that's really important for the 1A cosmology stuff, because we're going to be leveraging Rubin for the lower redshift end of stuff as well. But the other thing I wanted to ask was, in terms of the community providing additional products, is that going to be ingested, might be the wrong word here, as almost like higher level science products, but with a different name? And is the procedure for that and the requirements for that clearly documented somewhere?
Yes, we expect the community to contribute further. There's been talking about something similar to the high-level science products. We're finalizing the details as we speak, with discussions between MAST and the Project Science Office, and we're planning to document this as soon as possible.
Wonderful, thank you.
Right, Leo.
So my question is from Ori's talk. Why were the high redshift supernova light curve fits so poor? I didn't mean it that way. I mean, why are they, why don't they fit better?
Well, I mean, the signal to noise, there's a few reasons. The low signal to noise, they're not taking into account upper limits, because right now Stardust 2 does not take into account upper limits, and we didn't plot them because it got really messy. So we just made this plot actually last night. And we were going through versions and yeah, we didn't plot upper limits, but there's like hundreds of upper limits there, and it's hard to take that into account in the fits. The other thing is we don't have great models for what a Redshift 2 supernova will actually look like. So there's a lot of different type 2 supernovae that you might imagine, and you're extrapolating these to higher redshifts. So there's a lot of different reasons. And so we need to build more libraries. We need to update Stardust 2. We need to get better ideas about our error budget. So all these different things.
So like, for example, a few of the light curves were looked pretty flat.
Yeah.
And then the fit did whoop. So
Yeah.
were some of those points early or late in the light curve, were those actually limits?
No, I don't think they were. I think you have time dilation. You're working in different wavelength bands. Your type 2 has this plateau. So there's a lot of different things going on there, which, yeah, we still need to sort out.
Okay, thanks.
Okay, so we'll go to Rebecca, and then I see that Tahere has her hand up online. So Rebecca first, and then.
So, Ori, and I was going to be honest, I also had that question, but we should talk because we might be able to help.
Good comment. All right, Tahere, if you wanted to unmute and ask your question or give your comments, please feel free to do so.
Yes, hello. I have a question from the last speaker. I want to ask that in the slide that she showed the videos and the Jupyter notebook, the data that maybe I didn't get it well. The telescope we observe it, and then at the same time the data will available, and we can analyze the data at the same time. Is it correct?
So Tahere, just to make sure I understand the question correctly, is it real-time analysis of the data that you're asking about?
Yes, yes.
Okay, do you want to take that? Oh, yeah.
Sorry, what do we mean with real-time analysis? Are we streaming the data directly
Yeah,
and
maybe
be
about
able to analyze them directly? Yes. As I said, from the Nexus, they are co-located with the tools, with the compute, and so you can analyze the data without downloading them or egressing them. And we're trying to do this both from the MastUI interface as well as from the Nexus itself, and bridge between the two.
Okay, thank you very much.
Thanks for the question, Tahere.
Yeah, bye.
Okay. Any other points on this? Azali?
So I think this is a question maybe for Jacob. So you mentioned that different epochs of data might have different epochs of references. And I'm wondering how that will be communicated. Like, I'm thinking about, you have a light curve, and your transient may be in a reference at one epoch and not at another epoch. And is there an easy way that I can figure out, these 3 points have the same epoch and these points have different epoch references? Or is that in the metadata of each alert? And is the date in the metadata, or is it just a reference name? Or...
Yeah, that's a great question. So, I mean, you'll have at least the reference cut out, and then, yes, some sort of ID or, something that tags you like this reference was used for that. So you could easily sort all of your data points in your light curve, which reference are they tied to? In terms of like a date for the reference, of course, it will be some stack of whatever dates were available in that field. And so how you want to define your average or your min and your max, could be sort of up to you or up to the science case. So that's maybe a slightly more difficult question to answer. But yeah, does that give you a a sense?
Yeah, that's helpful. You also mentioned something like you were looking at stacking 6 images together for a reference.
Oh, that was just we're using a certain set of the Open Universe sims to build references, and the 13 fields that we're running are the ones where there were enough, at least 6 images to include in the reference image, but that's not sort of indicative of, the reference image scheme for the real schedule. That's just based on the Open Universe. And so, I imagine it'll be something more akin to like using the pilot data to build a first set of templates for all of those fields, which should be sort of more uniform coverage.
Thanks.
Sure.
Just to follow up on that, this gets even more complicated in the RISE alert streams that Lynn and Ori described, because the same transient will be there in multiple streams, right? It'll be there in the single image streams. It could be there in the 8 image stacks and the 16 image stacks, 32 image stacks. So you have to pay attention to, in the alert stream, there'll be force photometry on those stacks and in the individual images, right? So you'll have to pay attention to the force photometry on the reference image as well as in that single image sequence, the 16 image sequence, the 32 image sequence. So you'll have all the information there in the alert packets, but it's a more complicated alert packet because they're not all single images anymore. And they all might have different reference images as well. So the information about which images went into the reference will be in the alert packets and what type of stack it is and the date ranges, but you just have to figure out how to work with all these different pieces of data together to make your light curve.
Yeah, any other thoughts on this? All right, I'm going to open up to more questions here. If not, we can break for the coffee, but I want to make sure we have some time to discuss things. Okay, everyone wants a coffee? Okay. All right, thanks everyone for the discussion. Let's thank all the speakers again.